This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. The origin of species by means of natural selection, or the preservation of favoured races in the struggle for life. 6th London edition by Charles Darwin. Chapter number 9, Hybridism. Section 1 of 2. Contents of this chapter. Distinction between the sterility of first crosses and of hybrids. Sterility, various in degree, not universal, affected by close interbreeding, removed by domestication. Laws governing the sterility of hybrids. Sterility not a special endowment, but incidental on other differences not accumulated by natural selection. Causes of the sterility of first crosses and of hybrids. Parallelism between the effects of changed conditions of life and of crossing. Dimorphism and trimorphism. Fertility of varieties when crossed and of their mongrel offspring not universal. Hybrids and mongrels compared independently of their fertility. Summary. The view commonly entertained by naturalists is that species, when intercrossed, have been specially endowed with sterility in order to prevent their confusion. This view certainly seems at first highly probable, for species living together could hardly have been kept distinct had they been capable of freely crossing. The subject is in many ways important for us, more especially as the sterility of species when first crossed and that of their hybrid offspring cannot have been acquired, as I shall show, by the preservation of successive profitable degrees of sterility. It is an incidental result of differences in the reproductive systems of the parent species. In treating this subject, two classes of facts, to a large extent fundamentally different, have generally been confounded, namely the sterility of species when first crossed and the sterility of the hybrids produced from them. Pure species have of course their organs of reproduction in a perfect condition, yet when intercrossed they produce either few or no offspring. Hybrids, on the other hand, have their reproductive organs functionally impotent, as may be clearly seen in the state of the male element in both plants and animals, though the formative organs themselves are perfect in structure as far as the microscope reveals. In the first case, the two sexual elements which go to form the embryo are perfect. In the second case, they are either not at all developed or are imperfectly developed. This distinction is important when the cause of the sterility, which is common to the two cases, has to be considered. The distinction probably has been slurred over, owing to the sterility in both cases being looked on as a special endowment, beyond the province of our reasoning powers. The fertility of varieties, that is, of the forms known or believed to be descended from common parents, when crossed, and likewise the fertility of their mongrel offspring, is, with reference to my theory, of equal importance with the sterility of species, for it seems to make a broad and clear distinction between varieties and species. Degrees of sterility. First, for the sterility of species when crossed and of their hybrid offspring. It is impossible to study the several memoirs and works of those two conscientious and admirable observers, Kölreuter and Gärtner, who almost devoted their lives to this subject, without being deeply impressed with the high generality of some degree of sterility. Kölreuter makes the rule universal, but then he cuts the knot, for in 10 cases in which he found two forms, considered by most authors as distinct species, quite fertile together, he unhesitatingly ranks them as varieties. Gärtner also makes the rule equally universal, and he disputes the entire fertility of Kölreuter's 10 cases. But in these and in many other cases, gardener is obliged carefully to count the seeds in order to show that there is any degree of sterility. He always compares the maximum number of seeds produced by two species when first crossed, and the maximum produced by their hybrid offspring, with the average number produced by both pure parent species in a state of nature. But causes of serious error here intervene. A plant, to be hybridized, must be castrated, and what is often more important, must be secluded in order to prevent pollen being brought to it by insects from other plants. Nearly all the plants experimented on by Gärtner were potted and were kept in a chamber in his house. That these processes are often injurious to the fertility of a plant cannot be doubted, for Gärtner gives in his table about a score of cases of plants which he castrated and artificially fertilized with their own pollen, and, excluding all cases such as leguminosae, in which there is an acknowledged difficulty in the manipulation, half of these 20 plants had their fertility in some degree impaired. Moreover, as Gärtner repeatedly crossed some forms, such as the common red and blue pimpernels, Anagallis arvensis and Caerulea, which the best botanists rank as varieties, and found them absolutely sterile, we may doubt whether many species are really so sterile when intercrossed as he believed. It is certain, on the one hand, that the sterility of various species when crossed is so different in degree and graduates away so insensibly, and on the other hand, that the sterility of pure species is so easily affected by various circumstances that for all practical purposes it is most difficult to say where perfect fertility ends and sterility begins. I think no better evidence of this can be required than that the two most experienced observers who have ever lived, namely Kölreuter and Gärtner, arrived at diametrically opposite conclusions in regard to some of the very same forms. It is also most instructive to compare, but I have not space here to enter on details, the evidence advanced by our best botanists on the question whether certain doubtful forms should be ranked as species or varieties, with the evidence from fertility adduced by different hybridizers, or by the same observer from experiments made during different years. It can thus be shown that neither sterility nor fertility affords any certain distinction between species and varieties. The evidence from this source graduates away, and is doubtful in the same degree as is the evidence derived from other constitutional and structural differences. In regard to the sterility of hybrids in successive generations, though Gärtner was enabled to rear some hybrids, carefully guarding them from a cross with either pure parent for 6 or 7, and in one case for 10 generations, yet he asserts positively that their fertility never increases, but generally decreases greatly and suddenly. With respect to this decrease, it may first be noticed that when any deviation in structure or constitution is common to both parents, this is often transmitted in an augmented degree to the offspring, and both sexual elements in hybrid plants are already affected in some degree. But I believe that their fertility has been diminished in nearly all these cases by an independent cause, namely by too close interbreeding. I have made so many experiments and collected so many facts, showing on the one hand that an occasional cross with a distinct individual or variety increases the vigour and fertility of the offspring, and on the other hand that very close interbreeding lessens their vigour and fertility, that I cannot doubt the correctness of this conclusion. Hybrids are seldom raised by experimentalists in great numbers, and as the parent species, or other allied hybrids, generally grow in the same garden, the visits of insects must be carefully prevented during the flowering season. Hence hybrids, if left to themselves, will generally be fertilized during each generation by pollen from the same flower, and this would probably be injurious to their fertility, already lessened by their hybrid origin. I am strengthened in this conviction by a remarkable statement repeatedly made by Gärtner, namely that if even the less fertile hybrids be artificially fertilized with hybrid pollen of the same kind, their fertility, notwithstanding the frequent ill effects from manipulation, sometimes decidedly increases and goes on increasing. Now, in the process of artificial fertilization, pollen is as often taken by chance, as I know from my own experience, from the anthers of another flower, as from the anthers of the flower itself which is to be fertilized. So that a cross between two flowers, though probably often on the same plant, would be thus effected. Moreover, whenever complicated experiments are in progress, so careful an observer as Gärtner would have castrated his hybrids, and this would have ensured in each generation a cross with pollen from a distinct flower, either from the same plant or from another plant of the same hybrid nature. Thus, the strange fact of an increase in fertility in the successive generations of artificially fertilized hybrids, in contrast with those spontaneously self-fertilized, may, as I believe, be accounted for by too close interbreeding having been avoided. Now let us turn to the results arrived at by a third most experienced hybridizer, namely the Honourable and Reverend W. Herbert. He is as emphatic in his conclusion that some hybrids are perfectly fertile as the pure parent species, as are Kölreuter and Gärtner that some degree of sterility between distinct species is a universal law of nature. He experimented on some of the very same species as did Gärtner. The difference in their results may, I think, be in part accounted for by Herbert's great horticultural skill, and by his having hothouses at his command. Of his many important statements, I will here give only a single one as an example, namely that, quote, every ovule in a pod of Crinum capense, fertilized by Crinum revolutum, produced a plant which I never saw to occur in a case of its natural fecundation, unquote. So that here we have perfect, or even more than commonly perfect, fertility in a cross between two distinct species. This case of the Crinum leads me to refer to a singular fact, namely that individual plants of certain species of Lobelia, Verbascum and Passiflora, can easily be fertilized by the pollen from a distinct species, but not by pollen from the same plant, though this pollen can be proved to be perfectly sound by fertilizing other plants or species. In the genus Hippeastrum, in Corydalis as shown by Professor Hildebrand, in various orchids as shown by Mr. Scott and Fritz Muller, all the individuals are in this peculiar condition, so that with some species certain abnormal individuals, and in other species all the individuals, can actually be hybridized much more readily than they can be fertilized by pollen from the same individual plant. To give one instance, a bulb of Hippeastrum orlicum produced 4 flowers. 3 were fertilized by Herbert with their own pollen, and the 4th was subsequently fertilized by the pollen of a compound hybrid descended from 3 distinct species. The result was that, quote, the ovaries of the 3 first flowers soon ceased to grow, and after a few days perished entirely, whereas the pod impregnated by the pollen of the hybrid made vigorous growth and rapid progress to maturity, and bore good seed which vegetated freely, unquote. Mr. Herbert tried similar experiments during many years, and always with the same result. These cases serve to show on what slight and mysterious causes the lesser or greater fertility of a species sometimes depends. The practical experiments of horticulturists, though not made with scientific precision, deserve some notice. It is notorious in how complicated a manner the species of Pelargonium, Fuchsia, Calceolaria, Petunia, Rhododendron, etc. have been crossed, yet many of these hybrids seed freely. For instance, Herbert asserts that a hybrid from Calceolaria integrifolia and Plantagenea, species most widely dissimilar in general habit, quote, reproduces itself as perfectly as if it had been a natural species from the mountains of Chile, unquote. I have taken some pains to ascertain the degree of fertility of some of the complex crosses of rhododendrons, and I am assured that many of them are perfectly fertile. Mr. C. Noble, for instance, informs me that he raises stocks for grafting from a hybrid between Rhododendron ponticum and Catorbiense, and that this hybrid, quote, seeds as freely as it is possible to imagine, unquote. Had hybrids, when fairly treated, always gone on decreasing in fertility in each successive generation, as Gartner believed to be the case, the fact would have been notorious to nurserymen. Horticulturists raise large beds of the same hybrid, and such alone are fairly treated, for by insect agency the several individuals are allowed to cross freely with each other, and the injurious influence of close interbreeding is thus prevented. Anyone may readily convince himself of the efficiency of insect agency by examining the flowers of the more sterile kinds of hybrid rhododendrons, which produce no pollen, for he will find on their stigmas plenty of pollen brought from other flowers. In regard to animals, much fewer experiments have been carefully tried than with plants. If our systematic arrangements can be trusted, that is, if the genera of animals are as distinct from each other as are the genera of plants, then we may infer that animals more widely distinct in the scale of nature can be crossed more easily than in the case of plants. But the hybrids themselves are, I think, more sterile. It should, however, be borne in mind that, owing to few animals breeding freely under confinement, few experiments have been fairly tried. For instance, the canary bird has been crossed with 9 distinct species of finches, but as not one of these breeds freely in confinement, we have no right to expect that the first crosses between them and the canary, or that their hybrids, should be perfectly fertile. Again, with respect to the fertility in successive generations of the more fertile hybrid animals, I hardly know of an instance in which 2 families of the same hybrid have been raised at the same time from different parents, so as to avoid the ill effects of close interbreeding. On the contrary, brothers and sisters have usually been crossed in each successive generation, in opposition to the constantly repeated admonition of every breeder, and in this case it is not at all surprising that the inherent sterility in the hybrids should have gone on increasing. Although I know of hardly any thoroughly well authenticated cases of perfectly fertile hybrid animals, I have reason to believe that the hybrids from Cervulus vaginalis and Revesii, and from Fascianus colchicus with Fascianus torquatus, are perfectly fertile. Monsieur Quatrefages states that the hybrids from 2 moths, Bombyx cynthia and Arindia, were proved in Paris to be fertile inter se for 8 generations. It has lately been asserted that 2 such distinct species as the hare and rabbit, when they can be got to breed together, produce offspring which are highly fertile when crossed with one of the parent species. The hybrids from the common and Chinese geese, A. cygnoides, species which are so different that they are generally ranked in distinct genera, have often bred in this country with either pure parent, and in one single instance they have bred inter se. This was effected by Mr. Ayton, who raised 2 hybrids from the same parents but from different hatches, and from these 2 birds he raised no less than 8 hybrids, grandchildren of the pure geese, from one nest. In India, however, these crossbred geese must be far more fertile, for I am assured by 2 eminently capable judges, namely Mr. Blythe and Captain Hutton, that whole flocks of these crossed geese are kept in various parts of the country, and as they are kept for profit, where neither pure parent species exists, they must certainly be highly or perfectly fertile. With our domesticated animals, the various races when crossed together are quite fertile, yet in many cases they are descended from 2 or more wild species. From this fact we must conclude either that the aboriginal parent species at first produced perfectly fertile hybrids, or that the hybrids subsequently reared under domestication became quite fertile. This latter alternative, which was first propounded by Pallas, seems by far the most probable and can indeed hardly be doubted. It is, for instance, almost certain that our dogs are descended from several wild stocks, yet, with perhaps the exception of certain indigenous domestic dogs of South America, all are quite fertile together. But analogy makes me greatly doubt whether the several aboriginal species would at first have freely bred together and have produced quite fertile hybrids. So again, I have lately acquired decisive evidence that the crossbred offspring from the Indian humped and common cattle are, inter se, perfectly fertile, and from the observations by Rutimeyer on their important osteological differences, as well as from those by Mr. Blythe on their differences in habits, voice, constitution, etc., these 2 forms must be regarded as good and distinct species. The same remarks may be extended to the 2 chief races of the pig. We must therefore either give up the belief of the universal sterility of species when crossed, or we must look at this sterility in animals not as an indelible characteristic, but as one capable of being removed by domestication. Finally, considering all the ascertained facts on the intercrossing of plants and animals, it may be concluded that some degree of sterility, both in first crosses and in hybrids, is an extremely general result, but that it cannot, under our present state of knowledge, be considered as absolutely universal. Laws governing the sterility of first crosses and hybrids. We will now consider a little more in detail the laws governing the sterility of first crosses and of hybrids. Our chief object will be to see whether or not these laws indicate that species have been specially endowed with this quality, in order to prevent their crossing and blending together in utter confusion. The following conclusions are drawn up chiefly from Gartner's admirable work on the hybridization of plants. I have taken much pains to ascertain how far they apply to animals, and considering how scanty our knowledge is in regard to hybrid animals, I have been surprised to find how generally the same rules apply to both kingdoms. It has been already remarked that the degree of fertility, both of first crosses and of hybrids, graduates from 0 to perfect fertility. It is surprising in how many curious ways this gradation can be shown, but only the barest outline of the facts can here be given. When pollen from a plant of one family is placed on the stigma of a plant of a distinct family, it exerts no more influence than so much inorganic dust. From this absolute 0 of fertility, the pollen of different species applied to the stigma of one species of the same genus yields a perfect gradation in the number of seeds produced, up to nearly complete or even quite complete fertility, and, as we have seen, in certain abnormal cases, even to an excess of fertility, beyond that which the plant's own pollen produces. So in hybrids themselves, there are some which never have produced, and probably never would produce, even with the pollen of the pure parents, a single fertile seed. But in some of these cases, a first trace of fertility may be detected by the pollen of one of the pure parent species causing the flower of the hybrid to wither earlier than it otherwise would have done. And the early withering of the flower is well known to be a sign of incipient fertilization. From this extreme degree of sterility, we have self-fertilized hybrids producing a greater and greater number of seeds up to perfect fertility. The hybrids raised from two species which are very difficult to cross and which rarely produce any offspring are generally very sterile. But the parallelism between the difficulty of making a first cross and the sterility of the hybrids thus produced, two classes of facts which are generally confounded together, is by no means strict. There are many cases in which two pure species, as in the genus Verbascum, can be united with unusual facility and produce numerous hybrid offspring, yet these hybrids are remarkably sterile. On the other hand, there are species which can be crossed very rarely or with extreme difficulty, but the hybrids, when at last produced, are very fertile. Even within the limits of the same genus, for instance in Dianthus, these two opposite cases occur. The fertility, both of first crosses and of hybrids, is more easily affected by unfavourable conditions than is that of pure species. But the fertility of first crosses is likewise innately variable, for it is not always the same in degree when the same two species are crossed under the same circumstances. It depends in part upon the constitution of the individuals which happen to have been chosen for the experiment. So it is with hybrids, for their degree of fertility is often found to differ greatly in the several individuals raised from seed out of the same capsule and exposed to the same conditions. By the term systematic affinity is meant the general resemblance between species in structure and constitution. Now the fertility of first crosses and of the hybrids produced from them is largely governed by their systematic affinity. This is clearly shown by hybrids never having been raised between species ranked by systematists in distinct families, and on the other hand by very closely allied species generally uniting with facility. But the correspondence between systematic affinity and the facility of crossing is by no means strict. A multitude of cases could be given of very closely allied species which will not unite, or only with extreme difficulty, and on the other hand of very distinct species which unite with the utmost facility. In the same family there may be a genus, as Dianthus, in which very many species can most readily be crossed, and another genus, as Silene, in which the most persevering efforts have failed to produce, between extremely close species, a single hybrid. Even within the limits of the same genus, we meet with this same difference. For instance, the many species of Nicotiana have been more largely crossed than the species of almost any other genus. But Gärtner found that Nicotiana acuminata, which is not a particularly distinct species, obstinately failed to fertilize, or to be fertilized, by no less than 8 other species of Nicotiana. Many analogous facts could be given. No one has been able to point out what kind or what amount of difference in any recognizable character is sufficient to prevent two species crossing. It can be shown that plants most widely different in habit and general appearance, and having strongly marked differences in every part of the flower, even in the pollen, in the fruit and in the cotyledons, can be crossed. Annual and perennial plants, deciduous and evergreen trees, plants inhabiting different stations and fitted for extremely different climates, can often be crossed with ease. by a reciprocal cross between two species, I mean the case, for instance, of a female ass being first crossed by a stallion and then a mare by a male ass, these two species may then be said to have been reciprocally crossed. There is often the widest possible difference in the facility of making reciprocal crosses. Such cases are highly important, for they prove that the capacity in any two species to cross is often completely independent of their systematic affinity, that is, of any difference in their structure or constitution, excepting in their reproductive systems. The diversity of the result in reciprocal crosses between the same two species was long ago observed by Kölreuter. To give an instance, Mirabilis jalapa can easily be fertilized by the pollen of Mirabilis longiflora, and the hybrids thus produced are sufficiently fertile. But Kölreuter tried more than 200 times during 8 following years to fertilize reciprocally Mirabilis longiflora with the pollen of Mirabilis jalapa, and utterly failed. Several other equally striking cases could be given. Thuret has observed the same fact with certain seaweeds or fuci. Gärtner, moreover, found that this difference of facility in making reciprocal crosses is extremely common in a lesser degree. He has observed it even between closely related forms, as Mathiola annua and glabra, which many botanists rank only as varieties. It is also a remarkable fact that hybrids raised from reciprocal crosses, though of course compounded of the very same two species, the one species having first been used as the father and then as the mother, though they rarely differ in external characters, yet generally differ in fertility in a small and occasionally in a high degree. Several other singular rules could be given from Gärtner. For instance, some species have a remarkable power of crossing with other species. Other species of the same genus have a remarkable power of impressing their likeness on their hybrid offspring. But these two powers do not at all necessarily go together. There are certain hybrids which, instead of having, as is usual, an intermediate character between their two parents, always closely resemble one of them. And such hybrids, though externally so like one of their pure parent species, are with rare exceptions extremely sterile. So again, among hybrids which are usually intermediate in structure between their parents, exceptional and abnormal individuals sometimes are born, which closely resemble one of their pure parents. And these hybrids are almost always utterly sterile, even when the other hybrids raised from seed from the same capsule have a considerable degree of fertility. These facts show how completely the fertility of a hybrid may be independent of its external resemblance to either pure parent. Considering the several rules now given, which govern the fertility of first crosses and of hybrids, we see that when forms, which must be considered as good and distinct species, are united, their fertility graduates from 0 to perfect fertility, or even to fertility under certain conditions in excess. That their fertility, besides being eminently susceptible to favourable and unfavourable conditions, is innately variable, that it is by no means always the same in degree in the first cross and in the hybrids produced from this cross, that the fertility of hybrids is not related to the degree in which they resemble in external appearance either parent, and lastly, that the facility of making a first cross between any two species is not always governed by their systematic affinity or degree of resemblance to each other. This latter statement is clearly proved by the difference in the result of reciprocal crosses between the same two species, for, according as the one species or the other is used as the father or the mother, there is generally some difference, and occasionally the widest possible difference, in the facility of effecting a union. The hybrids, moreover, produced from reciprocal crosses often differ in fertility. Now, do these complex and singular rules indicate that species have been endowed with sterility simply to prevent their becoming confounded in nature? I think not. For why should the sterility be so extremely different in degree when various species are crossed, all of which we must suppose it would be equally important to keep from blending together? Why should the degree of sterility be innately variable in the individuals of the same species? Why should some species cross with facility and yet produce very sterile hybrids, and other species cross with extreme difficulty and yet produce fairly fertile hybrids? Why should there often be so great a difference in the result of a reciprocal cross between the same two species? Why, it may be asked, has the production of hybrids been permitted? To grant to species the same power of producing hybrids and then to stop their further propagation by different degrees of sterility, not strictly related to the facility of the first union between their parents, seems a strange arrangement. The foregoing rules and facts, on the other hand, appear to me clearly to indicate that the sterility, both of first crosses and of hybrids, is simply incidental or dependent on unknown differences in their reproductive systems. The differences being of so peculiar and limited a nature that in reciprocal crosses between the same two species, the male sexual element of the one will often freely act on the female sexual element of the other, but not in a reverse direction. It will be advisable to explain a little more fully, by an example, what I mean by sterility being incidental on other differences, and not a specially endowed quality. As the capacity of one plant to be grafted or budded on another is unimportant for their welfare in a state of nature, I presume that no one will suppose that this capacity is a specially endowed quality, but will admit that it is incidental on differences in the laws of growth of the two plants. We can sometimes see the reason why one tree will not take on another, from differences in their rate of growth, in the hardness of their wood, in the period of the flow or nature of their sap, etc. But in a multitude of cases we can assign no reason whatsoever. Great diversity in the size of two plants, or one being woody and the other herbaceous, one being evergreen and the other deciduous, and adaptation to widely different climates, does not always prevent the two grafting together. As in hybridization, so with grafting, the capacity is limited by systematic affinity, for no one has been able to graft together trees belonging to quite distinct families. And, on the other hand, closely allied species and varieties of the same species can usually, but not invariably, be grafted with ease. But this capacity, as in hybridization, is by no means absolutely governed by systematic affinity. Although many distinct genera within the same family have been grafted together, in other cases species of the same genus will not take on each other. A pear can be grafted far more readily on the quince, which is ranked as a distinct genus, than on the apple, which is a member of the same genus. Even different varieties of the pear take with different degrees of facility on the quince. So do different varieties of the apricot and peach on certain varieties of the plum. As Gardner found that there was sometimes an innate difference in different individuals of the same two species in crossing, so Sagaray believes this to be the case with different individuals of the same two species in being grafted together. As in reciprocal crosses, the facility of effecting a union is often very far from equal, so it sometimes is in grafting. The common gooseberry, for instance, cannot be grafted on the currant, whereas the currant will take though with difficulty, on the gooseberry. We have seen that the sterility of hybrids, which have their reproductive organs in an imperfect condition, is a different case from the difficulty of uniting two pure species, which have their reproductive organs perfect. Yet these two distinct classes of cases run to a large extent parallel. Something analogous occurs in grafting, for Thewin found that 3 species of Robinia, which seeded freely on their own roots and which could be grafted with no great difficulty on a 4th species, when thus grafted were rendered barren. On the other hand, certain species of Sorbus, when grafted on other species, yielded twice as much fruit as when on their own roots. We are reminded by this latter fact of the extraordinary cases of Hippeastrum, Passiflora, etc., which seed much more freely when fertilized by the pollen of a distinct species than when fertilized with pollen from the same plant. We thus see that, although there is a clear and great difference between the mere adhesion of grafted stocks and the union of the male and female elements in the act of reproduction, yet that there is a rude degree of parallelism in the results of grafting and of crossing distinct species. And as we must look at the curious and complex laws governing the facility with which trees can be grafted on each other as incidental on unknown differences in their vegetative systems, so I believe that the still more complex laws governing the facility of first crosses are incidental on unknown differences in their reproductive systems. These differences in both cases follow, to a certain extent, as might have been expected, systematic affinity, by which term every kind of resemblance and dissimilarity between organic beings is attempted to be expressed. The facts by no means seem to indicate that the greater or lesser difficulty of either grafting or crossing various species has been a special endowment, although in the case of crossing, the difficulty is as important for the endurance and stability of specific forms as in the case of grafting it is unimportant for their welfare. End of section 1 of chapter 9.